technically video number 2 on the practice test. You can check out the first video on Edmodo. It would be great to be able to have the same base 10, which we could change both to base 10. The first one's already base 10. The second one could be rewritten as 10 to the power of 1, 2, 3, 4, 5, 6, 7. 10 to the 7th. And of course, now that we have the same base, we could apply a common log to both sides so that the bases cancel out and the exponents come down, and you have your simple equation. So at this point, the 10s cancel out, the bases cancel out, you end up with a new equation that says 2n plus 10 equals 7. And if you subtract both sides 10, you'll end up with 2n equals negative 3, which means that your final answer will be n equals negative 3/2, or negative 1.5. Let's jump to the next one, number 5. Again, anytime you have an equation and you could get the same base, that would be great. Now, I noticed that there's a 3 here, and I could change this to move it up to change it to base 3. So this would be rewritten as 3 to the negative 1, and this technically could be rewritten as 3 to the 4th power. Again, you have calculators, all you got to do is use them, right? 3 to what power gives you 81? 3 to the 4th power gives you 81. So let's rewrite both of these bases as base 3 to certain powers. So now we really do have the base 3 on both sides, which means we could just eliminate them, but just don't forget that a power to a power you have to distribute. So negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. Bring down the equal sign. And over here, 4 times 3 is 12x. And 4 times 5 is 20. Now, the reason why I just wrote the exponents down as a regular equation is because if you were to apply log base 3 here, that'll cancel out. If you were to apply log base 3 there, that'll cancel out. And you end up with this equation down here. Okay? So now all we got to do is solve. Let me move the 12 over to the left side by subtracting 12x on both sides. And let me move it up to make some space. We end up with negative 13x on the left side. Plus 2 equals 20, of course. And now let's continue solving. Let's subtract 2 on both sides. And we'll have negative 13x equals 18 left over. My final step would be to divide both sides by negative 13. And that's our answer. X equals negative 18 over 13. Number 7, we have log base 3 of 8x minus 17 equals 6. If you want to get rid of the log base 3, what are you going to do? You're going to raise both sides to become powers of base 3. So I'm just going to write a big 3 on both sides. There it is, 3 to the log base 3, 3 to the 6. Let me put my equal sign between the 3's. Anyway, we know that it's going to cause it to cancel. And the 8x minus 17, that's going to come down. 8x minus 17. And then equals 3 to the 6th. And of course, with the calculator, let's do 3 to the 6th power. 729. After that, let's get rid of the 17 by adding 17 to both sides. We're going to have 8x equals 746. My final step will be to divide by 8 and divide by 8. And 746 is not divisible by 8. At the very least, you could reduce it by 2. Right? So your final answer, x equals 373 if you reduce it by 2 over 4. Now, ladies and gentlemen, keep in mind that this is a practice test that I made. I changed the values. My answers didn't come out that nice. I tried to make them nice. I wasn't able to. So
come out to be 93 and 1/4.
93 and 1/4 also. Yeah, if you change that to a mixed fraction, that's totally fine. On tomorrow's test, you'll see that the answers are nicer than these. The only ones you really have to worry about decimals are the ones where they say on the instructions to round to 4 decimal places. Let's move on, number 8. So Number 8, we're going to have to use the properties because you can't get rid of a log. Actually, I should say you can't get rid of 2 logs on one side. Okay? I could get rid of this log base 2 by raising it to be the power of 2, but over here I have 2 logs on one side, so I need to condense them. I need to take both of these logs and make them 1. I need to condense them using the properties. The first property that I'm going to use is the power property, where I take this 2 and I raise it so it could become a power, the power property, okay? And then after that, I'm going to look at my left side of the equation, and I do have a log base 2 here and a log base 2 here. Let's forget about this 2 because it's now an exponent of x. So we have log base 2 on both of them. I'm going to condense them to become one single log base 2. So this log and this log became that single log base 2. And the product property, because there's a plus sign, the product property says that when you condense them, you have to take this one and multiply it by this one. So the 0.5, I'm more comfortable with 1/2. So I'm going to think of this as 1/2 times x squared. What is 1/2 times x squared? It's simply 1/2 x squared. So let me write that. So we really have log base 2 of 1/2 x squared on the left side of the equation. And let me bring down the equal sign. Now let me take a look at the right side of the equation. The right side of the equation also has addition right there, which means that I'm going to be able to also condense this log base 2 and this log base 2 to a single log base 2. Again, with the product property. The plus sign means that we're going to be using the product property. If it were a minus sign, we'd be using the quotient property. So the plus sign gives us the product property. Product means multiply. I need to multiply the 5 times this 10. 5 times 10 is 50. So on the entire right side of the equation, we have log base 2 of 50. Let me put both of these together now. Let me write them together. Let me write that log base 2 of 50 right here. Of course, we're going to get rid of the log base 2's by raising both sides to become powers of base 2. And of course, we all know that 2 to the log base 2, that cancels out. 2 to the log base 2 cancels out. So you're going to have a new equation that simply says 1/2 x squared equals 50. It's algebra 1 time now. We're going to get rid of the 1/2 by multiplying both sides by 2. That'll cancel. Multiply by 2. You're going to have a new equation that says x squared equals 100. Let me make some space. X squared equals 100. Okay, and for my final step, to get rid of a square, I'm going to apply a square root. Keep in mind that whenever you apply a square root in an equation, you have to put a plus minus in front of your answer. X equals plus minus 10. However, when we go back to our original equation, does a positive 10 work? Does a negative 10 work? Well, you need to make sure that you don't end up with negatives inside the logarithms, and here's the only x. If you do plug in the negative 10 in there, it will not work, because you can't have log base 2 of a negative number. It just doesn't work. Try it on the calculator, it's going to say error, right? So it's only the positive 10, not the negative 10. So I would definitely not put the plus minus on your answer. That would technically be half wrong. It would only be x equals positive 10 only, not the negative 10. So don't put plus or minus 10, just put x equals 10.
So then we do square roots for logarithms.
Let's move to number 9. Number 9, again, we're going to be using the properties. Let's focus in on the left side first of the equation. We do have a log base 7 here and a log base 7 there. And we're going to condense it using the quotient property, not the product property. This is a minus sign, so we're going to use the quotient property. So log base 7 and log base 7 is going to become one single log base 7. And the quotient property, because we have a minus sign, we're going to use the quotient property, which means you're going to take this one and divide it by this one. So it will be a fraction right here, x plus 6 over 13. And that's it. We have condensed the left side of this equation. It says log base 7 of a fraction, x plus 6 over 13. The right side of the equation, let's take a look at the right side. There's nothing to do on the right side. Let me just rewrite it. Log base 7 of 144. And now we're going to raise both sides to be powers of base 7. Of course, 7 to the log base 7 cancel out. 7 to the log base 7 cancel out. We have a new equation that has x plus 6 over 13 equals 144. To get rid of the 13 on the left side, I want to multiply by 13. And of course, what I do to one side, I do to the other, multiply by 13. 13 cancels. We have x plus 6 equals a giant number. So you have x plus 6 equals 1,872. Let's subtract 6 on both sides, giving us a final answer of x equals 1,866. All right, let's jump to number 10. However, I noticed that number 10, I messed up when I changed values. It became not factorable, so we're gonna have to make a change on number 10. Let's do this change on number 10. Let's change the 34. I believe if we change that to a 30, we'll be okay. So let's change that to a 30 right there. 3, 0. Change that to a 30. So we're going to do log base 8 plus log base 8. The plus indicates that we're going to be using the product property. Let's condense. We don't want two logs on one side. So that log base 8 and that log base 8, let's write them as one single log base 8. And again, the plus sign indicates product property. Product means multiply. I need to multiply the x times x plus 30. I might as well show that work up here since I have a little bit of space here. X times x plus 30. And when I multiply x times x plus 30, I will get x squared plus 30x. So log base 8 of x squared plus 30x is what I have on the left side of this equation. Of course, the equal sign comes down. And on the right side, let's check if I have anything to do on the right side. Nothing to do on the right side. I'm just going to rewrite it. Log base 8 is 64. So I'm just noticing that you could actually take two paths here. You could continue to get rid of the logs and rewrite your equation, or you could actually do log base 8 is 64 and get the answer 2 on the right side.
Base 8, 64.
So like I said, you could do log base 8 is 64, and that would give you 2, but you'd still have to raise both sides to be powers of base 8, and that would give you 8 to the second power, which would take you back to 64 anyway. So I'm just going to go with the elimination of log base 8 by doing an 8 on both sides, or better said, base 8 on both sides. That cancels, this cancels. I have a new equation that says x squared plus 30x equals 64. Now from here I have a quadratic equation. I'm going to move the 64 to the left by subtracting 64. But of course I have run out of space, so let me move this over to the side and rewrite this equation up here. So we have x squared plus 30x minus 64 equals 0, and that could be factored. What times what is negative 64 that if you add together is 30? Now if you don't see it right off the bat, you might want to make a list of how to get negative 64. You get negative 64 by doing negative 1 times 64, or negative 2 times 32, or negative 4 times 16, I believe, or negative 8 times 8. So which pair of numbers combines together to give you positive 30? That would be the negative 2 and the positive 32. So we would plug in the minus 2 right here and the plus 32 right there. Now of course this is a factored form. And now we need to split them and solve using the zero product property. That means that x minus 2 could equal 0, x plus 32 could equal 0. And if you solve both, you're going to get x equals 2 and x equals negative 32. That's ugly. That is a disgusting 3. Anyway, we still need to double check and make sure we don't end up with negatives inside logarithms. Now, if we look at the answer, negative 32, when I plug it in right here into the x, that'll give you a negative inside a logarithm, so this is an extraneous solution. Does not work. The only real answer is x equals 2. If you write both, you get half of credit because half of what you wrote down is wrong. So keep in mind to always go back and check and make sure you don't end up with negatives inside logarithms. We're going to pick this up on the next video, jump into number 11 on the next video.